Today we're going to talk about carbon-14 dating. So carbon-14 dating is used to measure the carbon-14 within dead material such as wood, such as fossils. So let's try this example. A living tree has a carbon-14 decay rate of 13.6 counts per minute per gram. An old dried piece of wood from the same type of tree has decay rate of 3.4 counts per minute per gram. Estimate the age of the old piece of wood. The half-life of carbon-14 is 5,730 years. How many counts per minute per gram will be measured if the wood was 18,000 years old? So let's first answer the first problem. That's going to be estimate the age of the old piece of wood. So to do that, we already know the half-life of carbon-14. So we're going to first calculate the constant of decay. So that's going to be natural log of 2 divided by 5,730. So the decay constant is going to be 1.21 times 10 raised to the negative 4. So we already know what our values here. We have our A sub F. It's going to be the final amount. We only have a 3.4 left. That is the same wood. And we also have the A sub initial. That's going to be 13.6. So that's how much is the initial counts per minute per gram. So now what we're going to do is solve for the time here. So this is going to be negative ln A sub f divided by A sub 0 divided by k. And let's plug in what we know. So this is going to be the age of the old piece of wood. So it's going to be negative natural log of 3.4 divided by 13.6. And we have a constant here. That's going to be 1.21 times 10 raised to the negative 4. That's the decay constant. So the age of the old piece of wood is going to be around 11,456. So that's the, let's make this 57. Okay, here. So that's the 11,457 years. So that's the old piece of wood age. Now let's solve the second problem. How many counts per minute per gram will be measured if the wood was 18,000 years old? So if this wood have gone by 18,000 years old, what is going to be the final amount over here? So we already know the numbers here. So we're going to calculate the A sub f here, and we have A sub initial. That's going to be 13.6, and we have a Euler's number here, and we're going to raise it to the constant of decay. It's going to be 1.21 times 10 raised to the negative 4, and we have the time. That's going to be 18,000 years old. So now let's calculate how many counts per minute per gram will be measured here. So that's going to be 1.54 minute per gram. So that's it for this problem.